For our final video on conics, okay, not the final video in the section, but on conics, we're going to look at the last of the four conics, which is hyperbolas. And a hyperbola is the set of all points P in the plane such that the difference between the distances from P to two fixed points is a given constant. So if you recall, the definition of an ellipse is very similar to this definition of hyperbola. The only difference is the word difference here, okay? So instead of the focal radii being the sum of, instead of the sum of the focal radii being equal to a constant, now it's going to be the difference of the focal radii is equal to a constant, okay? And so that's going to change up our equation just a little bit from an ellipse, but you'll see it's still very similar. So if we're given a hyperbola with center 0, 0, foci negative c0 and c0, so that means that our foci are on the x-axis, and a difference of focal radii 2a, then the equation is x squared over a squared minus y squared over b squared equals 1, where b squared is equal to c squared minus a squared. So it's very similar to an ellipse. The difference is that minus sign in the middle, okay? Now, some interesting features about hyperbolas. Hyperbolas have what we call two branches in the graph. And they are boundaries to those branches. They're not going to cross certain lines. And if you remember, that sort of phenomena is where you would have an asymptote on the graph. So hyperbolas have two asymptotes, always. Okay, it's not a hyperbola if it doesn't have two asymptotes. And the equation of the asymptotes in this case are y equals b over ax and y equals negative b over ax. And the b and the a simply come from the a squared and b squared in the equation itself. So if you have the equation, you have your b and your a, and so your asymptotes are pretty easy to figure out. Now, if the foci are on the y-axis instead of being on the x-axis, so we have 0, negative c, and 0, c, then the equation is y squared over a squared minus x squared over b squared equals 1, where b squared is equal to c squared minus a squared, and the equation of the asymptotes flip. So now it's y equals a over bx and y equals negative a over bx. Again, those come straight from the equation. The c still means the distance, okay, to the center, because the center of a hyperbola is the midpoint of the line segment joining its foci. And if you need to know where that is, that's in your notes on the first page. Hyperbolas do have centers, and the foci, the distance from the foci to the center is always c, okay? A few other things, if you note that the asymptote, the numerator always of these fractions goes with the y term in the equation. Okay, that's important to know as well. Additionally, if you've noticed by now, the a squared term goes with the positive one. So whereas before a squared was always the larger denominator in an ellipse, now a squared always belongs to the positive term in the equation, no matter what, okay, even if it's the smaller one. So let's look at some examples. In 4, we're given the equation 4x squared minus y squared is equal to 16. And we need to graph the hyperbola and find its foci, okay? So first thing we got to do is get it into the standard form of a hyperbola, which means we got to make sure we got a minus sign, which we do. And then we've got to make sure that it's equal to 1. So we're going to divide everything by 16. And we get x squared over 4 minus y squared over 16 is equal to 1. So a squared is equal to 4 because that first term is positive, and b squared is equal to 16, and that means that c squared must be equal to b squared plus a squared. There's a typo in the notes on that. So that's 4 plus 16, so that's just 20. So my distance from my center to my foci is going to be plus or minus square root 20, which is just plus or minus 2 root 5. So my foci are 2 root 5, 0, and negative 2 root 5, 0. A few other things we need to figure out are the asymptotes, right? So we need to know what A is. A is 2, and B is 4. So we've got the asymptotes y is equal to, since, remember, the y term always goes on top, b is my y, so that's going to be 4 over 2x, and y equals negative 4 over 2x. which is just y equals 2x, y equals negative 2x for my asymptote lines. And so now that we have pretty much everything we need, we're going to graph. And you're probably wondering, where do I get these points from? Since the equation is a positive x squared, that means our hyperbola is going to have only x-intercepts, and we can double check that. The way to double check it is to solve for x-intercept. Okay, so that means we plug in 0 for y. So we get x squared over 4 minus 0 is equal to 1, x squared is equal to 4, x is equal to plus or minus 2. Now let's say we try to solve for the y-intercept. Okay, so this time we plug in 0 for x, right? So then we get negative y squared over 16 is equal to 1, y squared is equal to negative 16. Now this would be an imaginary number, yes? So since this is an imaginary number, there are no y-intercepts, right? Because we can't graph imaginary number on a real plane. So that's why with hyperbolas, you're only going to have two intercepts, either 2x or 2y, and that's going to tell you if you have horizontal hyperbola or a vertical hyperbola. So now we're going to graph. First thing I'm going to plot are my x-intercepts, so 2 and negative 2, here and here. And then I need to draw my, excuse me, my asymptotes. So that means I have a line y equals 2x, so I rise 2, run 1. So 1, 2, 1, 1, 2, 1, 1, 2, 1, 1, 2, 1. And continue that line either direction, okay? So then, and then we've got the line, so let me draw that line for you guys. Okay, and then we've got the other asymptote, which is y equals negative 2x, so we are down to the right 1, like so. And then go the other direction. Okay, so this is my other asymptote here. And notice the asymptotes are always dotted lines, okay? So we've got y equals 2x, which you need to label, y equals negative 2x. We've also got to plot our foci, which were 2 square root 5, 0, and negative 2 square root 5, 0. So that's somewhere around like negative 4, I want to say, because square root 5 is like 2.1-ish. So I'm going to plot them near 4, a little past 4 actually, so 4 and negative 4. And I'm just going to label them F1, F2. And then now that I've plotted everything I know, I'm going to graph my hyperbola. So you start at your intercept and you go towards your asymptote, but you should never cross your asymptote, okay? It's a boundary. You go towards the asymptote, you don't ever cross it, and you don't ever touch it. So my graphs start going towards them, but they should not cross them. Okay, and there's my graph. So now let's look at 6. It says 4x squared minus 9y squared plus 36 is equal to 0. So we need to solve this to get it into standard form of a hyperbola. So we're first going to move the 36 to the other side. And then I'm going to divide everything by negative 36. So I get negative x squared over 9 plus y squared over 4 is equal to 1. So I'm going to rearrange this so the positive term comes first. It's a little easier to read off my a. So y squared over 4 minus x squared over 9 is equal to 1. So a squared is equal to 4. B squared is equal to 9. And then our c squared must be the 2 added together, so that's 13. So c is equal to plus or minus square root 13. So my foci are square root 13, 0, negative square root 13, 0. Okay, and then my asymptotes, now notice that the a squared term always goes to the positive term, and the positive term is y squared. So it's going to be our second equation. So we've got y equals a over b, so that's going to be 2/3 x and y equals negative 2/3 x. And then the last thing to do is to realize since the y squared term is the positive term, that means that I'm going to have y-intercepts but not x-ones. So this is going to be y squared over 4 is equal to 1, y is equal to plus or minus 2. And I'm going to plot that. So 2, negative 2. Okay, and then we've got our asymptotes at y equals 2/3 x and y equals negative 2/3 x. So that's going to be rise 2 over 3. So 1, 2, 1, 2, 3, 1, 2, 1, 2, 3, 1, 2, 1, 2, 3. Okay, and keep going. Okay, so this is roughly somewhere near my line. Like so. And then now I got to do the other one, which is negative 2/3. So down 2 over 3, down 2 over 3. Okay, so this is, I'm going to mark this one, y equals negative 2/3 x, and y equals 2/3 x. And then I need to plot my foci. So that's square root 13, 0, negative square root 13, 0. That's larger than square root of 9, which is 3, but smaller than square root of 16, which is 4. So it's in between 3 and 4. So I'm going to just pick some place in between 3 and 4, like so. This is F1. Excuse me. And this is F2. And then I draw my graphs. Remember, my hyperbolas will start at my intercepts and then go towards my asymptotes. So towards my asymptotes, but never touching them and never crossing them. And they shouldn't move away either. So if you gave me a graph, let me draw this in red. If your graph looked like this, that is wrong. The blue is right. So you should go towards my graph, not towards them and then away from them. Okay, they should always go towards it. Don't touch them, don't cross them, but don't move away either. Okay. Now that we've done some graphing, let's figure out equations from pieces. All right, so if we look at 14, they give us the foci, negative 4, 0, and 4, 0, and then the difference of the focal radii has to be 4. What's nice about looking at this is that for foci, it's kind of simple to tell which hyperbola we have, right? Because this is foci on the x-axis. So that means we're looking at an x squared over a squared minus y squared over b squared equals to 1 hyperbola equation. And then the difference of the focal radii has to be equal to 2a, right, in order to fit into our two different equations. So 2a has to be equal to 4, so a is equal to 2. So that means a squared has to be, you got it, 4. Okay, and then you're like, well, how do I figure out b? Now remember b, or b squared, is equal to c squared minus a squared. We said that in the very beginning on the first slide. So all we have to do is figure out what c is. But we know what c is because the formula for the foci is negative c0 and c0. So c is just 4, so c squared is 16. So we've got b squared must be equal to 16 minus 4, which is 12. And then we plug in. So our equation is x squared over 4 minus y squared over 12 equals 1. And we're done. So let's look at 16 then. In 16, they give us the foci, 0 square root 6 and 0 negative square root 6. And then they give us the asymptotes, y equals square root 2 over 2x and y equals negative square root 2 over 2x. First thing to note is that our foci are on the y-axis, right? So that tells me my hyperbola equation is going to be y squared over a squared minus x squared over b squared equals 1. And my asymptote formulas are going to be y equals a over bx and y equals negative a over bx. So we just need to fit what we were given in terms of that. So that means that square root of 2 is a, and negative square root of 2 is a, and b is 2. Yes? So that means that if a is square root 2, then a squared is 2. And if b is 2, then b squared is 4. Now that we have a squared and b squared, we just simply plug into the equation. So y squared over 2 minus x squared over 4 is equal to 1. And that's our answer. Okay, final stretch here. So for 28, we're given the equation of hyperbola, not on standard form, and it's an inequality. So first we need to solve a hyperbola, get all the pertinent information in order to solve it and graph it, and then figure out how to shade these. Okay, these tend to be a bit tricky on the shading. So first thing we got to do is get the 4y squared on the left side. So we're going to subtract both sides by 4y squared. And then we're going to divide everything by negative 36. But remember, when we divide by negative, we flip the sign. So this becomes negative x squared over 4 plus y squared over 9 is less than 1. Okay, and so since it's less than 1, which apparently was another typo on the notes, I'm very sorry. It should be less than, not greater than. Okay, so our positive term is y squared, negative term is x squared. So that means that a squared is equal to 9, so a is plus or minus 3. And b squared is equal to 4, so b is equal to plus or minus 2. Which means that c squared is equal to 13, so c is equal to plus or minus square root 13. And then we need to figure out our asymptotes, which is just a over b, right? So our asymptotes are y equals 3 halves x and y equals negative 3 halves x. And we're going to plot. So since we have a y squared positive term, that means our hyperbola is going to be on the y-axis. So we've got 3 and negative 3 as our plots. And then our asymptotes are rise 3, run 2. So rise 3, run 2, rise 3, run 2, rise 3, run 2. And going the other way. Draw our graph. Not a very straight asymptote. I apologize. And then we go down 3 to the right 2. Okay, so we've got y equals 3 halves x and y equals negative 3 halves x. And then we don't really need to plot the foci because they don't help us here, and they weren't asked to graph, okay? So then our hyperbolas go towards our asymptotes, never crossing and never touching. Like so. So now that we have a graph for hyperbola, we need to figure out what area are we exactly shading here. And so one of the quickest way to figure it out is to test values. So if we plug in, I don't know, let's just say negative 2 for x and 0 for y. Okay, so that would be at this point right here. That would end up being a negative 1, which is less than 1. So that is inside our shaded region. So we actually end up shading in is everything in between our two hyperbolas. So that would be this area right here, okay? And make sure that your hyperbolas are dashed. I can't dash them anymore without just getting rid of everything. So they should be dashed. The graph in the notes is correct. I did not dash my graph because it's a little too hard on this thing, okay? And that's our graph for inequality. For 28, we're given y equals square root x squared plus 1. Okay, so first instinct, you see that radical. That means we have half of our graph, okay? So we automatically know just by seeing that radical, half of our graph. Whatever our graph is, ellipse, parabola, circle, hyperbola, it's half. And then we also notice that it's positive in front of the radical, right? So we only want y positive values. We don't want anything less than x. It's y equals, all right? And now we just need to figure out what the graph of our hyperbola would look like in general. So we're going to square each side. We get y squared is equal to x squared plus 1. So y squared minus x squared is equal to 1. This is standard equation, right? So a squared is 1. So a is plus or minus 1. B squared is also 1. So b is equal to plus or minus 1. And so c squared is 2. So c is plus or minus square root 2. And then we need to figure out our asymptotes. So our asymptotes are going to be y equals a over b, which is just 1, and y equals negative a over b, so negative 1. And then we graph what we have. So we know that since the y squared term came first, this is going to be a y-axis parabola, right? And we only want all positive values of y, so we're not going to graph anything below the x-axis. So when we graph this, I'm going to zoom in a little bit so you can see it a little better. We have our y-intercept 1, 0, and we don't plot negative 1, 0 because it would make our graph, I wouldn't fit inside the radicals domain, okay? And then we need to graph our asymptote, which is just y equals x. Which looks something like that. And y equals negative x. Okay, like so. And so then our hyperbola, the half that we're graphing, is the half above the y-axis. So that would be an entire branch going towards our asymptotes but never crossing them. Like so. Okay, and that's the graph. Oh. All right, and that's it. So the classwork due on the 8th, okay, so you will have 2 class periods to work on this, and it will hopefully not take very long once you get a hang of all the formulas. And it's page 430, numbers 1 through 21 odd, 25, and 27.